So this is a review of the charging function of the 2021 Chevy Bolt. We've had it for about 5 to 6 months now, and it's doing some weird stuff, and I kind of wanted to document this to see if anybody else had the same problem.
So this is my setup that I'm using to charge my Nissan Leaf. I've had this charger for about 6 years. It's worked flawlessly. As you can see here, it's a level 2, set for a level 2 charger at 30 amps. So that should be sufficient enough to power a Nissan Leaf or a Chevy Bolt. So here it's obviously showing it's not charging, there's no power, and this is probably the most important thing here is I've charged 16,911 kilowatt hours, or basically 16.9 megawatt hours, so roughly 17 megawatt hours over the last 6 years. This thing has, again, performed flawlessly. I've got it hooked up here to kind of a dry receptacle so I can kind of take this out if I need to be mobile and connect it somewhere else. This runs through conduit into my junction box about, I don't know, 7 feet away, or sorry, my breaker panel about 7 feet away. I think this is either 6 or 8 gauge THHN wire, and then it's breakered by, I believe, a 40 or 50 amp breaker inside the breaker box. So it's wired correctly, so I know there's no issues with respect to getting power. The system itself, when it turns on, the voltage might dip a little bit from 244 is normally what our household voltage is, down to about, I don't know, 242, 243, and that's normal. So I'm almost absolutely sure this is not the issue. I've taken this down to charge the Chevy Bolt at the same rate that I charge the Nissan Leaf, which is roughly 6.6 kilowatts, and the power that gets drawn on my energy monitoring system also kind of shows that same kind of dirty power profile. So 99.9% sure it's not this box. Again, this has worked flawlessly, and it's all it basically is. It's a complicated contactor or relay this doesn't do any charging. All it does is basically supply power to the car's charging system. The charger is inside the car itself. So all this does is basically, once you plug the J1772 connector in, there's some call it safety stuff that goes on, and then some handshaking, and then the box here will communicate what its potential is with respect to how much current it can source out, and then the charger on the Bolt or the Leaf or any other EV car that gets connected will then charge according to what this capability is. And so that's basically kind of the setup of how all this stuff kind of works. GM advised consumers to basically park their car away from their house, not in their garage. I bought an extension cable, so this is basically a 25-foot extension. I think this is 32 or 35 amp rated. This one's 40, but anyway, I'm doing way less than 35 amps, so we're good in that department. And basically all this kind of does is, this will slip into here and kind of lock in, and basically that's the extension cable, so it allows me to keep my car outside and still charge.
So I wanted to capture a power profile of what the car is doing when it's charging, and I got a monitoring system on my house so I can see exactly what's happening here. So when we originally bought the car, this is what we'd see for a charging profile. It's fairly flat, roughly halfway to the end, and you see this little taper tail off, and that's what normally happens when you're charging the car. And as we've had this car, the power profile has gotten dirtier and dirtier, and we've also noticed that the car would randomly just stop charging, so we don't know if it's overheating or what's going on. So as you see here now, the same thing, I've just kind of marked it up. We got one blip there that's higher than 10 kilowatt hours, and then the other green part, which is the normal behavior of how a car should charge. So this is the power profile 3 months after the car's been driven, and as you can see here, there's a point in the charging cycle where the charger literally goes to 0 kilowatts, meaning there's no power going into the car. And you see that on a consistent basis, and I call that dirty power. Here's another example. We had the car plugged in to charge overnight, and as you can see, that the first part, the charge is stopped for no apparent reason, and then 3 to 4 hours later you have a little blip of it seems to try to start charging again. So again, I don't know what's happening here. Here you can see it shut off right about 10 o'clock, and for 6 hours it sat idle, didn't do anything, and then magically right around 4 o'clock it started charging again. Again, the cable was plugged in overnight, nothing was touched, nothing was changed, and it just stopped charging.
Okay, so this is basically the J1772 plug. In other words, it's a jargon for the electric plug that you use to plug your car. So here's basically how the plug works. If you look at the top two receptacles here, these are for AC power. So this is where the actual power will come out. And then there's a ground right here, and there's two receptacles here, or plugs, whatever you want to call them. And these are used to basically tell the car that the cable is plugged in, as well as it signals from the charger, or I'm sorry, if you want to call it this, not really a charger, but the outlet here, what its ampacity or capacity is to source energy to the car. So in this case, its ampacity is rated at 30 amps, so the car knows that it can charge at 30 amps or below. So it'll never charge at, well, at least it shouldn't, never charge higher than 30 amps. So there is a couple signals, like I said, that come out of this connector. I'll spare you all the technical details. That basically, there's a pulse width modulation signal that tells the car how much the wall outlet, or this little, we'll call it EVSE charger, so to speak, can supply to the car. So if the charger only has 20 amps, it'll only supply 20 amps, and the car should only take 20 amps.
So I want to go over how the charging process works with respect to the EV plug. So here on the left hand side is the charger, that's what you want to call it. On the right hand side there's the car, and there's a voltage inside the car that basically provides a voltage divider to make sure that the connectors are plugged in. Once that happens, 12 volts is applied to the car, and via voltage divider sets a voltage out, and the controller in the car detects that, and then basically flips that K1 switch, and then adds another resistor into this setup, which basically lowers the voltage. The controller will see that, and then it will basically flip the switch on, and basically tells it what power to charge the car at. Now when it terminates the charge, the 12 volt controller on the car will open that switch, change the resistance in the circuit, and then the detector will detect that and basically turn off the pulse width modulation and open the contactor, stopping the power from flowing to the car. So what I think is happening is something in the car is flipping that K1 switch off, which then changes the voltage and causes the detector to turn off K2, which essentially then terminates the charge. And so I think that's being generated by the car with some kind of charging fault issue, and that's why the charger is turning off. Okay, here you can see I'm going to plug in the EV connector and see what kind of happens. So the light will come on the dash and will blink, kind of indicating with the charge, as well as, depending on how hot it is externally, there's some fans that come on in the grill. They're fairly loud, and you'll see that later on. So again, it's almost certain that it's not in the connector, because I can charge my Leaf with no problems, and it works fine. So this has to be somewhere inside the car, and the charging system, or it's detecting something with the batteries. Anyway, so I'll go over to the front of the car here, and you can hear the fans kind of kick on, and hear the lights kind of going off saying it's being charged. So the fans are fairly loud, small blowers going off, and so I guess when the batteries get fairly hot, the fans will kick on. It's about 90-ish degrees outside, so they're going pretty well. Yeah, they're fairly loud. One of the things I don't like about the Volt, but other than that, I think it's a really good car, but they fix the battery problems. And here you can see the top of the car. The lights are still going, so it's charging. Alright, luckily enough I was able to catch this problem in progress, and here's what I'm seeing.
We are charging the Bolt. I've probably been a half an hour into charging, and it stopped charging. So it's showing its vehicle status as being connected here, and it's pulled in roughly, I don't know, 5 kilowatt hours. So there's definitely something wrong here. Basically, when it's connected, it should show charging, but here again, this will kind of be a kilowatt hour counter. So as the car charges, you'll see that number start to go up, or basically charge, and then once it reaches 66 kilowatt hours, it'll stop. But basically they're signaling there's something wrong here. This should be increasing as time goes on, and it's not. So I think it's somewhere in the car. I'm almost 100%, 99.99% sure that's what's going on.
Okay, now we're back out at the Bolt, and as you can see, the LED charging indicator has done nothing. It's not flashing. It usually does when it's charging. The cable here is connected, and so what I'll do is I'll push this little button here, and that will kind of reset the car, thinking that the connector is now plugged in, and hopefully it'll start charging again. And I want to go in and kind of verify that on the LCD display. It looks like here it's charging again, but again it's been connected. It just randomly stopped for no apparent reason, and every once in a while we'll get charge interruption notifications to the phone saying the charging stopped, but it doesn't tell you why. And so you're kind of left scratching your head. As we rolled back the battery capacity to the 90% that GM recommends, only charge it to 90%, that seemed to have alleviated the issue, as well as we only drive it down to 70 miles and then charge it. So we lose 70 miles of driving as well as the 90% charge from the top part of the battery. So we're losing over 100 miles until the fix comes out. So basically, I still can't explain why the car is basically triggering the charger or the box inside to shut off.
Now we're back at the charging station here. So I toggled the switch on the handle, and it looks like it's now starting to charge, which is kind of bizarre. Again, this works perfectly fine on my Nissan Leaf. I haven't had any issues. So now you can see the energy, or the Coulomb counter here, energy counter, is starting to go up. It's starting to tick up. So now the car is being recognized by the charger. So something is shutting this car off. And I'm almost certain to say that it's within the car, because if I had the same problem on my Nissan Leaf, I'd be doing the same thing, and it does not. So the charger and the cable and the connector are common to both cars, and only the Chevy Bolt has the issue. So it seems to be the Chevy Bolt.
Okay, here's my Nissan Leaf with the same cable plugged in. Okay, if you have a Chevy Bolt and you're also a victim of the recall, please leave a comment below and let me know if you've seen similar problems or incidents with your car. I'd like to hear other users' feedback. And as always, please like and subscribe to the channel.